Okay, so for this passage here, just like our other ones, remember when you're doing the science section, your goal is to get through it quickly. You have 40 questions in 35 minutes. So the best thing to do is to read the introduction to what you're looking at and then go to the questions rather than trying to read and interpret everything. So let's take a look up here. So this says, passage 2, a teacher provided the table below to the students in a science class. The table gives 5 properties for each of samples A through H. The students were told to assume that each sample is a completely solid cube composed of a single hypothetical pure substance. Okay, then it gives us this table. We're not going to look at it right now because, again, we don't know what they're going to ask about it. And then this little bottom blurb down here, the teacher asked each of 4 students to explain how these data could be used to predict which samples are composed of the same substance. Okay, so that's our intro here. The teacher has some data, the students are looking at data, and they're trying to say, hey, here's how you can pick what's the same. So let's jump straight into the questions. We're not going to worry about the students right now, reading all 4 of them. First of all, it's a waste of time. Second of all, we'll possibly get confused about, wait, was that student 2 or 3 that said this thing? And end up having to read it anyway. So let's go to question 7 here. Based on student 1's explanation, the same substance composes both of the samples in which of the following pairs? Okay, so we have A and B, B and C, C and D, and D and E. Okay. Now, this is where now we can come over and read student 1. Student 1, if 2 samples have the same value for all 5 properties, they are composed of the same substance. If 2 samples have different values for any of the 5 properties, they're composed of different substances. So he says, hey, they have to be exactly the same. So real quick, looking at A and B, they have different melting points, so that's not a pair. B and C have different mass and different volume. Those are different. C and D, however, those are exactly the same. Okay, all 5 of their values, mass, volume, density, melting point, boiling point, those are all the same. So our answer is just going to be C. Samples C and D are all the same, and that's according to student 1's explanation. Okay, now we have to do some flipping back and forth. Excuse me. Based on student 3's explanation, the same substance composes both of the samples in which of the following pairs? Okay, a very similar question, except for this one, we're looking at student 3. Okay. Student 3, if 2 samples have the same mass, volume, and density, they are composed of the same substance. If 2 samples have different values for any of these 3 properties, they're composed of different substances. Neither melting point nor boiling point by itself can distinguish between substances. So student 3 says, hey, if mass, volume, and density are the same, it's the same thing. So let's take a look at our things. So we have A, C, B, E, F, G, G, H. So let's take a look which ones have the same. So AC doesn't. I do notice that G and H have the same pairs of mass, volume, and density, which is J. Those are the ones that have the same pair. Okay. Now, number 9, suppose that the temperature of sample A is increased to 250 degrees at 1 atmosphere of pressure. At 250 degrees Celsius, would sample A be a solid or a liquid? Okay, so this one now is looking straight at these melting points and boiling points. So if you remember, it says that each sample is a completely solid cube. So as you heat things up, it could melt. So number 9 is asking about sample A. It's increased to 250 degrees. So sample A melts at 126 degrees. So once you've passed that, it's now a liquid. It doesn't boil until 750 degrees. So if it's at 250 degrees, it has all melted. It's all a liquid now, and it's not yet a gas. So we can come down here And it's not going to be these two. It's not a solid. It's going to be a liquid. And it's a liquid because the melting point is 126. So C right there. Number 10. Consider the claim that two samples having the same density will always be composed of the same substance, regardless of the values of the other four properties. Which of the students, if any, would be likely to agree with this claim? So this is saying, hey, if density is the same, they're the same thing. Which students agree with that? Now, here's where we can finally read our other student samples. Notice that we've been saving time and brain space by not trying to read it. Now, we've already read student 1, who said that all 5 things have to be the same. So saying student 1 would not say just having density be the same would be good. Now, student 3, we've also looked at. They said if they have the same mass, volume, and density. So they also would not say density alone is good enough to tell us they're the same things. Okay, student 2 said if two samples have the same values for any 3 or more of the 5 properties, they are composed of the same substance. So student 2 doesn't care what the properties are as long as there's 3 or more that are the same. But density alone is not good enough for student 2. Student 4, if two samples have the same density, melting point, and boiling point, they're composed of the same substance. So he says, again, density alone is not good enough. So for number 10 here, none of the students would say if density is the same, and that's it, they're good enough. Number 11. Which of students 2, 3, and 4 would be likely to agree that sample A and B are composed of the same substance? So let's take a look. So student 2, if two samples have the same value for any 3 or more of the 5 properties, then they are the same. So let's take a look at A and B here. And right away I can see A and B have the same mass, volume, density. So student 2 would say they are the same thing. That's 3 of the 5 things. Student 3 specifically says mass, volume, and density. So student 3 would also agree. And student 4 says they have to have the same density, melting point, and boiling point to be the same substance. Now, A and B do not have the same melting and boiling point. So the ones that agree are student 2 and student 3. We can come down here. That's going to be option A, student 2 and student 3. Also, I apologize for flipping back and forth. This is the best I got right now. Luckily, when you take actual tests, you don't have to do this as much. Okay, number 12. Consider the statement, two samples that have the same mass, volume, density, and boiling point are composed of the same substance, even if the two samples have different melting points. Which of students 2 and 4, if either, would be likely to agree with this statement? Okay, everything's the same except melting points. So they're saying it'll have mass, volume, density, boiling point, all the same. Let me erase these extra things. Okay, melting point can be different, right? They don't care about that. So, and they want to compare student 2 and student 4. Who would say they're the same? So student 2 says if two samples have the same value for any 3 of the 5. And this says, hey, yeah, this has got 4 of the 5 that are the same. So student 2 would definitely agree in that. Just checking that I read that right. Student 4 says if two samples have the same, density, melting point, and boiling point. So student 4 says they have to have density, melting, and boiling. Now, they don't have the same melting point, so student 4 is not going to agree with this. So student 2 is the only one who would say those two are the same. Suppose that the temperature of sample D is increased to 890 degrees Celsius at 1 atmosphere of pressure. Will the sample's density be lower than or higher than it was at 20 degrees and 1 atmosphere? So let's take a look. This one is using a little bit of outside knowledge. Most questions don't use very much outside knowledge. This one does. So sample D, when it gets up to 890, let's double check. Yep, 890 degrees Celsius. Notice that it's going to melt at 230 degrees, and then at 885 is actually going to boil. So at this point, sample D is going to be a gas. Okay, it will have all boiled away. It will just be vapor or gas. So the question is, will the density be lower or higher than it was at room temperature when it was just a solid? Now, gases typically have a lower density than a solid. Right? Gases are much more spread out. They're flying around. So we'll be able to say here that for this one, it will definitely have a lower density. And the reason for that is the best answered with A, it will be a gas. Letter B here says it will be a liquid, which we saw from the chart that it will actually be melted. And there you go.